On October 9th, 2022, astronomers observed GRB 221009A, the brightest gamma ray burst in history. You viewers at home may be asking yourselves, what is a gamma ray burst? Or even, why should I care? So to answer those questions, I'll explain what gamma ray bursts are, where they come from, how GRB 221009A was discovered, and what it means for the fields of astronomy and physics. So what is a gamma ray burst? Gamma ray bursts are beams of energy which, as their name suggests, are made up of gamma rays, the most energetic form of electromagnetic radiation. They are typically short-lived and their duration can vary from between under a second to multiple minutes. While the gamma rays that this phenomenon is named after are relatively quickly exhausted, they are followed by lower energy photons like X-rays, ultraviolet light, visible light, infrared light, and radio waves. So now that we know what a gamma ray burst looks like, how are they formed? The variance in duration seen in gamma ray bursts is indicative of their multiple possible origins. The shortest lived gamma ray bursts, which can only last for up to a few seconds, are thought to be the result of two neutron stars, which are the result of a star dying in a supernova and the leftover mass not being large enough to generate a black hole, colliding with each other and forming a black hole. The longer lasting gamma ray bursts, which can continue for up to several minutes, are thought to come from the deaths of extremely massive stars. When their cores collapse and do form black holes, there is still some matter from the star's exterior left surrounding them. This matter forms a disk around the black hole's circumference as it swirls inwards. This process channels electromagnetic radiation into two beams, one being fired from the top and one from the bottom of the black hole, each being perpendicular to the rotating disk of material. These beams are what we call gamma ray bursts. So, now that we know what they're made of and how they are made, how did we see GRB 221009A from Earth? Well, GRB 221009A was originally named Swift J1913.1 plus 1946, as it was so luminous that when it was originally recorded by NASA's Swift Observatory, it was thought to be a burst of X-rays that had originated from somewhere within our own galaxy. After it was also recorded by the Fermi Space Telescope, however, astronomers realized that they were dealing with a more energetic event, a gamma ray burst that had originated from further away. After this correction was made, significantly more attention was given to observing this astronomical occurrence and its trail of less energetic radiation, and it was given the catchy name GRB 221009A that we know it by today. So, now that we know how we discovered GRB 221009A, what makes it so significant? Well, as I mentioned when first introducing it, GRB 221009A was the brightest gamma ray burst that astronomers have ever recorded. Additionally, it came from a source that was unusually close to the Earth. You may be surprised to hear that GRB 221009A originated approximately 2 billion light years away from Earth, given that I just referred to it as being unusually close. It is important to remember, however, that on an astronomical scale, 2 billion light years is not as far away as it sounds, especially when considering that the average gamma ray burst seen from Earth is an order of magnitude further away. GRB 221009A's combination of intrinsic luminosity and proximity to the Earth is invaluable, as astronomers and physicists have been able to record more accurate and previously unavailable data. GRB 221009A has provided an opportunity for astronomers to further research the processes within black holes that create gamma ray bursts and the physics that surround them. This improved data may also allow astronomers to prove that the kinds of supernovae that generate gamma ray bursts are also responsible for the formation of certain heavy periodic elements like gold, silver, platinum, uranium, and thorium. So, that's what gamma ray bursts are, how they're formed, how we found GRB 221009A, and what it can teach us. I hope you learned something, and have a good day.